In this video, we are going to see tolerance zone. Before that, if you want to see this video in Tamil language, link in description. So kindly check it once. And don't forget to subscribe our channel and turn on the bell icon for further notification. And before you see this video, kindly see the previous video that I have explained about GD&T and ASME. Once you see that and come here, you will get more knowledge on this concept. And did you know how products are accepted or rejected in industries based on GD&T concept? So, I am your Spark. Let's go and watch. Normally in industries, importantly, they are see these 5 matters, that is size, shape, allowable tolerance, location and material condition. So based on this 5 specification, the products are accepted or rejected. To calculate this specification, tolerance zone are created. On earlier stage, we are all using this square tolerance zone. It is formed by XY method to calculate the product specification. But now we are not using this concept. Now we are using circular tolerance zone. This is formed by GD&T method. Now you have a question. Why we have rejected this square tolerance zone? Before that, we have to know one thing. Normally in industries, no products can be manufactured with 100% accuracy and 100% precision. It is impossible to manufacture. So we can't able to get 100% accuracy and precision on its size, shape, location. To overcome this, allowable tolerance is created. During World War II, we used this square tolerance zone. I will clarify its use in industry by some example. For this, we can take this nut and bolt combination. We can take nut for more clarity. For nut, this is the axis line, and for nut, this is the center point. If this nut's center axis is located inside the tolerance zone, then the nut is accepted. If it is not inside the tolerance zone, then it is rejected. We will see how to check this by its calculation. So now we just imagine some dimensions for calculation. So the center point of the nut should be 20 plus or minus 0.05 mm distance in both horizontal and vertical direction when we calculated it from any corner to the center point of the nut. So now we have a doubt on this 20 plus or minus 0.05 distance. Already we know there is no product can be manufactured with 100% accuracy and 100% precision. This 20 mm and 20 mm distance from corner point is the true position of the nut. But we are not able to manufacture it. So they give some tolerance value, that is plus or minus 0.05 mm. Now its total tolerance distance is 19.95 mm to 20.05 mm. Now we can create the nut within this distance from the corner point of the nut. Now we are going to see how to create the tolerance zone for this nut. Normally, tolerance zone area is calculated by add the value of plus or minus 0.05 mm. So in horizontal direction, tolerance zone distance is 0.05 mm plus 0.05 mm is equal to 0.1 mm. And also in vertical direction, tolerance zone distance is 0.05 mm plus 0.05 mm is equal to 0.1 mm. Then this tolerance zone is located inside the center of the nut. Now we can going to see the process of selection and rejection. So in the tolerance zone, the blue color represents the accepted nut and the red color represents the rejected nut. So you can see this figure. If these center points are located inside the tolerance zone, then this nut are accepted. If the center point are located outside the tolerance zone, then these nuts are rejected. For more clarity, you can see this figure. Here, the center point of the nuts are located inside the tolerance zone. So these nuts are accepted. And these nuts center points are located outside the tolerance zone. So these nuts are rejected. But these rejected nuts are also workable one. Due to this square tolerance zone, so many rejections are occurred in industries. At that time, they have a doubt. This nut is located outside the tolerance zone, but it is also fit for the bolt. So they are too confused. At that time, they are all see the differences in the distance of this rejected nut. You can see here, this blue dot is the longest distance of this tolerance zone. But this point is located inside the tolerance zone. And this red dot is located outside this tolerance zone, but its distance is lesser than this longest distance. To overcome this problem, they created the circular tolerance zone. It is created by GD&T method. This circular tolerance zone is created by just draw the circle by longest length in its corner point. When compared to the square tolerance zone, it gives 57% greater tolerance zone in circular tolerance zone. Due to this, rejections are reduced in industries, so productions are increased. So this circular tolerance zone is created by Stanley Parker. Now we are going to see how these nuts are accepted in circular tolerance zone. You can see here the center point of the nut is located inside this circular tolerance zone, then these nuts are accepted. When we are using square tolerance zone, these all three nuts are rejected because this center point of these nuts are located outside of this tolerance zone. But now we are using circular tolerance zone. You can see here the center point of the nut is located inside the circular tolerance zone. So only two nuts are rejected and one nut is accepted. Now we are using this nut for the bolt. So I hope now we understand what is circular tolerance zone. Now this method is used in industries. So I will continuously upload the videos on mechanical concept. Thank you for watching this video and don't forget to like this video. So if you have any doubts, kindly comment it and turn on the bell icon. And don't forget to subscribe our channel.